All right. Hello, everyone. Thank you for joining us today on this hybrid event where we are coming back to in person, both online and in person. There are a mix of developers and startup founders coming today to learn more about cloud scale analytics. And today we are glad to have Ahmed, who is joining us to speak about today's topic. There are different parts in today's presentation where we'll go deeper into the topic. And we are, again, Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as learn from industry-leading ideas and technology from Microsoft partners on the open source community. And I have the pleasure of leading the hub in the UAE, which is actually creating impact across the Middle East and Africa. So without any more, I would love to welcome Ahmed to the stage. Thank you, Ahmed.
Hello, everyone. I hope that you had a good day and a productive one. My name is Ahmed Mustafa. I'm a lead architect for data and AI in Microsoft. I work in a unit in Microsoft that is called Customer Success Unit. My unit is basically responsible of making our customers successful in their journey in the cloud. My focus within this unit is, as I said, in data and AI and IoT. So basically everything that is touching data, regardless if it's at rest or in motion. Today, I'm going to basically be talking to you about what we call and what we define as the cloud scale analytics. This is going to be a journey of a series of sessions that we're going to have today. And basically, this is going to, the main objective of it, to set your mindset of what are the differences between the traditional way of building data projects and analyzing data and building AI on-prem or in your own machine, and when you think at really large scale, especially when you are leveraging the cloud. There is huge differences, and basically the main objective of this session is to basically prep you for that. There is so many technical challenges, and there is so many complications when you are moving to the cloud and when you are moving and building large-scale solutions and applications, especially in the analytics domain. There is complexities that are related to the actual architecture that is basically being built on premise or in your own machine. The architectures are not designed for scale. You are having a lot of limitations in terms of hardware, in terms of memory, in terms of data itself, and the amount of compute that you can do. There is also a lot of teams. The more data that you get, the more use cases that you need, and the more insights that you want to drive, there is more people that are engaging with this data. And this is raising a lot of complexities in terms of governance, in terms of security, in terms of access control, in terms of how to manipulate the data and how to look at the data in terms of its maturity even. Data can easily be poisoned, can easily be biased, and can easily be skewed. So you can really it's very, very difficult, and it's getting more difficult to control this complexity. In addition to that, there is also uncertainty. There is constant evolution of trends and options. There is tons of technologies that are evolving, tons of projects, open source projects, closed source projects, and there's a lot of limitations that goes with this as well. Which one of these are production ready? Which one of these can really scale to the need, to the demands? Which of these can scale up to the real-time aspects or the huge big data that you want to, the internet level or the planetary scale of computation that you want to do? It's very, very difficult. Which one of these are actually secure? There is a lot of poisoning that can happen even on the open source projects that people are using. So the management of such uncertainty is very, very complicated as well. And there is also, because of that, there is, it's not clear how to move and how to go. And sometimes we see a lot of customers and a lot of organizations are facing like a really hard wall after a lot of investment of how they move forward. And after they have invested in a lot of architectures, basically these architectures are not computationally scalable anymore. Another complexity that is happening is the governance. As I said, governance is actually getting quite an important aspect. There is so much data that is out there, and so many people that are touching this data. And this is making a lot of complexities on so many different levels. You have personal data, you have GDPR laws that are protecting the data. Everyone is now entitled to know where the data is being stored, how the data is being processed. If you are building an application that is processing such data, you are really required to track the lineage of this data, to know where this data is, this data is being processed, which systems and which system are storing it, for how long, etc., etc. And things are getting more complex and complex because of that. The more systems, the more integrations that you are doing with different entities, the more things can get really messy easily. And then the fourth challenge is the skilling. With all of these technologies and with every hype that is happening in the technology, especially in the data and AI now, there is a new product, there is a new project, there is a new skill that you have to learn. How you can adapt your current skill set with the upcoming trend, and how you can always be on the cutting edge of the side of things, while in the same time maintaining that this trend of technology is not really going to tumble the actual projects and the actual implementations, because a lot of projects can start with a lot of hype, with a lot of enthusiasm, and then all of a sudden they lose lack of track because maybe a more interesting project that is there. So how you can really spot on the actual project, the actual gem that can really sustain the existence of your project and your ecosystem. And then eventually, as a consequence of everything that I've mentioned, the time to value is quite a challenge. With all of this big data, processing big data is becoming a challenge. It takes a lot of time. So you cannot process big data on a single machine. You cannot process big data on a small data center. And even on a small data center, you have the challenge of the resilience of this data center. What if this data center fails? What are the means of backing up this data, and how fast you can go offline? There is a lot of challenges when it comes into that. So even if you are having a whole rack of servers that are maintaining your data, and even if you are including a lot of replicas on your data, what happens if this rack with all of these replicas basically go fail for any disruption of electricity or hardware failures? So how you can make sure that you have geo-redundancy. There is a lot of concepts that have to be considered when you are looking into this and you want to serve customers, or you want to serve people, or you want to serve community at a planet scale. So you have to make the data as close as possible. You have to make the compute as close as possible to the people, or basically to who is accessing and requesting the service, which is another challenge that cannot be achieved by the cloud, by the on-prem environments. For that, in Microsoft, we have been thinking of how we can solve these problems. And we have introduced basically the cloud scale analytics principles. The cloud scale analytics principles consist of multiple artifacts and set of reference architectures and guidance. We start by the cloud adoption framework. We have defined a lot of principles that people can use, people can follow on how they start adopting the cloud in a more scalable way. This framework will help you to align your business, as well as also the technical aspects, as well as also the data science and the infrastructure. It can govern the overall architecture of your solution to make sure that you can grow without breaking your architecture. One of the most challenges is that when you start with an architecture, and the more that you're building on it, and this architecture is not resilient enough, your application will break. And maintaining such thing is going to be very, very costly in the future. So you really need to think ahead. We provide you also with reference architectures that you can leverage and you can kickstart out of the box, and you can have those architectures as foundations to your applications and to your systems. These modular building blocks, we kind of like imagine them as like Lego blocks. You can plug them together to make sure that you can scale up and down based on your needs. And those architectures are free. So basically, all of this is pure knowledge that based on our experiences in the different teams, the Microsoft 365 or the Office or the Xbox teams or the Azure team, the cloud team, and the business facing, basically we have come up with all of these different reference architectures. I'm going to walk you through them as well. And all of that is available for basically for the community to benefit from. And we also provide assessments. These assessments that you can perform yourself, or you can get more support from our dedicated teams. And those assessments can really help you, on one side, to understand the maturity level of your organization and your team and the readiness of the overall organization. And also the assessment will provide you with a roadmap of how you can evolve, how you can step up and improve this maturity level and go forward from there. Along of this capabilities, we provide also the skilling. And the skilling is also, just as the reference architectures, the skilling is also coming as a whole bunch of it is also for free. Everything is available online, as well as also with hands-on. So basically to make sure that we can empower as much of the community as possible without having to pay money just to learn. In addition to that, so once you have known your architecture, once you have verified how you can move, which technologies you would go, what is your maturity level, we provide you also with the deployment templates, also for free. So basically, you don't have to write everything from scratch. You can leverage these deployment templates to build and deploy the architectures, and then you can focus only on your workload, whether it's going to be code or low code and no code kind of like application, or a data science workload, machine learning algorithm that you want to train and eventually deploy and serve to your customers. You can definitely do that. And then eventually, if you want to scale and go beyond what we offer you the principles to make sure that you are building a well-architected architecture. And we do have this framework that can teach you also how you can build a really resilient architecture. And this goes into the well-architected framework. So the main objective of this is basically to empower the teams by facilitating this growth and this transformation, and to make sure that teams and organizations become data-centric and data-focused. And the transition really happens and really need to happen by switching the control from the IT centralized environments and organizations into having a federated data ownership where teams are aware of their data. Teams are aware of what they are doing. And this comes it's not an easy task, and there is a lot of challenges that comes with it. Staying with a centralized IT has a lot of benefits and has a lot of also disadvantages. The centralized architecture can provide some resilience because there is a one unified body that is providing this architecture and ensuring the governance. However, it increases the competency on the teams. There is time to value is being impacted because the IT is struggling to serve all of these different requesting bodies and requesting entities. So they had to put a priority on which to serve first, and which one is more complex and which one is not. And there is always, because of the limitations on the centralized IT approach, there is always limitations on infrastructure. Maybe there is not enough hardware, maybe there is not enough memory, or there is not enough resources to do the actual implementation or the actual deployment or the actual monitoring of the solution. So there's always one way or another that they have to find a workaround to make a problem. And then eventually the business that is actually focusing on the value, they're not able to be satisfied because they don't have control. They have access to the business, but they're not able to focus on the execution. They don't have control over the execution. However, if we go to the federated approach, we can still give the business and give the different teams the control over their data and provide them with a platform that have the common governance and improve the security and the agility. So the IT can be still in control, but on the business teams and the data science team and the data focus team can still focus on what they're doing best without having to worry about hardware, about skilling, or about resources, because they can be self-empowered. And this is basically how we can promote data, what we call as data stewardship, the awareness of the importance of data. And this eventually would increase the efficiency. So increasing the time to value, especially at this time, is very, very important. And this is basically the main objective of what you're doing. So before we look into the details of the cloud scale analytics, let's just take a step back. Let's explain a little bit about the cloud adoption framework itself, how CAF, how the cloud adoption framework can really help, what is the main essence behind it, and then we can look into how we can build on top of it. In the cloud adoption framework, there is a very common name that I'm expecting that you will start hearing about from now on a lot. It's called the landing zones. It's basically how you can design your landing zone for every single thing that is going to happen in the future. And the landing zone practically looks like this. The most important thing is the management group that you see here. This is where the policies will go. This is how you can ensure and enforce policies on everyone that is going to basically build a project in the cloud. So national security or data governance or data policies, masking rules, whatever that goes in there, basically would go in there. This is how the information security team can have the assurance that there is no leaking, there is no tampering with information, or there is no hacking, how they can secure that. Eventually, and also this connectivity subscription is also very important, how people can communicate, how systems can communicate with each other. So when there is a data team that is needing certain data from another data source, how can we enforce and ensure this connectivity while making sure that it's secure and it follows the principles and the guidance of the organization or the country that we're staying in. This would go also with the identity subscription. So everything that has happened to go in the cloud must make sure and must ensure that there is an identity that is attached to it, to make sure that there is no unauthorized access and there is no untampered access, basically, that is not authorized to do what it's supposed to do. And then eventually the management aspect itself. So in order for the different teams in the organization to start operating, the IT needs to provide them with a certain tooling that they can create environments, create new landing zones that is focused on their own business. And once they are done with their work, then basically this whole work can, for example, at some point, once you are done of it, basically it can be easily decommissioned. This is really important because the cloud adoption is also focusing a lot on the costs. Because if you are going and if you are staying on-prem, there is a lot of challenges with that. There is a lot of high cost that goes with it. You have to maintain the replicas, as I was saying. You have to maintain cooling. You have to maintain geo-redundancy, connectivity, and replica for the connectivity, and hardware refresh, and RAM refresh, and memory refresh. There is a lot of cost with maintaining your own, basically, farm of clusters or farm of servers or data center. So this comes with an additional cost that a lot of organizations have to think about a year or 5 years ahead that they have to budget for. With the cloud, basically, you don't have to do that because all of this is being shifted to a cloud vendor that is ensuring the security, is ensuring the redundancy up to a level 4 of what we call. So basically, this is what we call like a 3 replicas of everything, even on the cooling side, on the hardware side, on the disks, and all of that. And in the same time, you can scale up and down at a lightning speed, so that you don't need to wait to order some piece of hardware and then wait for the supply chain to ship it. You don't need to do any of that. So basically, once you need a service, once you need a hardware, once you need your compute, you can get it. Once you're done, you can shut it down, and you're only paying basically for what you're consuming. So this model is very, very appealing to a lot of organizations because it puts them really in control. And actually, the surprising fact is that we have realized and we have seen that a lot of customers that are actually using their own data centers, they're not using even their data centers up to its full potential. So there is a lot of wasted cost in that. However, they cannot downsize, because if they downsize, they are risking, if the business grows, they cannot accommodate it. So this is one of the other challenges, how you can size, how you can manage and plan ahead of time. So with this, once you have that, and once you enforce how people will start developing, how people will follow the processes of DevOps and ML ops and data ops, then people can start having their own sandboxes. People can start having their own data management landing zone. So as I said, the landing zone provides this foundational part to empower basically how we can manage data and how we can focus on the cloud scale analytics aspect. Once you have the cloud adoption framework in place and you follow the well-architected framework, you are capable now of creating what we call the data management landing zone. So the original cloud adoption framework would give the teams the ability to control and manage the infrastructure and the identity and the security and the overall general policies that will go with it. Then you need another landing zone for the data management itself. And the data management will basically provide what we call as the governance for the data specific and the related workloads. Once you establish this data management landing zone, then you can have the data landing zone itself, which is basically representing every single entity and every single business unit and how they can work. This architecture would basically provide you with the self-service, so you can easily create your own projects, the scalability that you need. You will not be hindered anymore because everything will be according to the policies, and at the same time, you can grow up and down or scale out and in as you need. And at the same time, it will be very fast to start. So one of the most tempting advantages of using the cloud is that you can start, as we say, like you can try fast and fail fast, learn fast, apply fast, deploy fast, grow fast. Because once you know that there is something that is wrong, you can easily cancel it. You don't have to go through and answer to why did you do this? Why did you order all of these millions of dollars of equipment that we don't need? No, with the cloud, it's much cheaper. So it's much easier to try and fail, and in the same time to find your own way. And then you'll be, with that, basically, you will be so much easier and faster to get into your results and to where you want to go faster. In the same time, security will be governed. Security will be guaranteed with that. You can easily enforce security on the data at rest, on the data in motion, and the data in compute as well. So we are also, like you can, for example, leverage what we call as confidential computing, where you can have security enclaves on the processors themselves. And then eventually you will reach out to the optimized operation. So this is what people really need. So in order to do that, there is a lot of impact and there is a lot of changes on the teams and the roles that the people will play, because the old silos will not apply. What we have learned in the traditional way of software development and engineering hardly applies in the modern world that we have in the cloud now, because there is so many different things and different roles, different hats that we need to wear. On the lowest level is the platform ops. There is solution architects that would work with the cloud engineers to build what we call as the platform operation. Basically, how to design, not only how to design, but also how to automate the creation of this platform. On top of it, there is the data platform ops. So once you have built this landing zone, the cloud adoption framework that is related for the infrastructure, then you are building the data management piece. There is data platform that needs to be built. In order to do that, you need to have data ops squads, you need to have cloud engineers, and you need to have also the solution architects that would design how the data platform would look like. Going higher, then basically you are focusing on the data landing zone itself, how the data is going to land. What is the nature of the data? What is the velocity of the data? Data comes in so many different ways. Data can be structured or semi-structured or completely unstructured, like emails, for example. You want to process on them, or maybe tweets. What is the nature of the data? And how this data is going to be stored on disk? Is it going to be stored on databases, or is it going to be stored purely on disks? Are you going to format it so we can speed up some analytics pieces, so we can speed up the further analytics pipeline eventually? There is tons of questions that come. Is the data is already stored, or am I going to ingest data? At how fast pace am I going to ingest this data? Am I going to stream this data? Am I going to work on it on a micro batches? Maybe every minute I'm going to get some data, or shall I be basically drinking from a fire hose, and I need to have a system and a platform that is capable of ingesting and processing in real time, or at least in near real time. So there is tons of questions, and with every question, there is a different architectural decision, because that's why we talk about the data platform decision is very, very important. After you have thought about how you are going to ingest your data and where you are going to store the data, there is another question: how you're going to process the data. Do you need the data in memory? Do you need the data to be stored eventually, and then you are going to just get some insight? Do you need to get insights in real time? This is what we call like complex events processing. So you're getting a lot of teeny tiny events, but you're not interested in those teeny tiny events. You're interested on the complex aspect of those events. When there is an anomaly that is happening, then you need to act. So there is a lot of options when it comes into data platform design. Once you have designed your data platform, then basically you can promote data stewardship, and you can promote data operations, and you can promote the actual analytics. And then you have more or less of the guarantee that this platform will not break with more data or with more requests that is asking questions against this data. So yeah. So if you recall, in the previous architecture that I have shown for the CAF landing zone, basically this is what you see here on the left. This is where the connectivity would happen, and here where the identity is, and where the management would happen. The landing zone for the data management, if you zoom in on it, you would see a lot of aspects on how we can manage the data. There is the identity, the data discovery aspects, and then eventually how you can control networking for basically people, how they can access. Because you cannot just limit, if you have your data in there, you need to enforce who can access this. Even on the metadata level, the information about the actual information, who can access it? Because the more information that you have, you will need to be able to find it. We're talking eventually about big data. And then we will need a service layer that enables every single thing that goes above to be able to serve it. So this is basically how you can manage everything from identity perspective, especially that we're not talking about people that are accessing the data. We're also talking about applications, systems, how you can enable the machine-to-machine communication. And you can imagine tons of use cases in self-driving cars, or where you need telecom data, and you need location intelligence with maps and satellites, and you need the computer vision to start processing and understanding what is happening on the road, and am I deviating from the lane? Do I need to stop? What is the speed limit? The cars are actually communicating with each other, at least the smart cars are communicating with each other. There's vehicle-to-vehicle communication. How to trim all of the noise. There is a lot of information that is going through the data platform, and then eventually the data platform publishes it back again. So all of this is happening through what we call as microservices and serverless compute. So the compute, whenever the platform needs something, it will trigger a serverless compute, it will do its job, and then it will kill it again because it doesn't need it anymore. And then eventually, the data that you have, regardless of its nature, you need to be able to understand and look at it from so many different angles. The data can be connected in a way or another. That's why we can visualize the data as a graph in a way, like tree and leaves, and everything is connected, and you need to traverse through the data to find some meaning. In order to do that, you need to have this on the data management level, because this is the level where it will have access, and it will provide the access to every vertical in the data landing zone itself. And then eventually all of that, as well as also the management plane of how you can control all of this, how you can expose access to the business users to find the business entities. When we are talking about data scientists will look at it from the raw level, CSV files and database tables. But business people and people that are working against the business in banks or in in customer service, they don't look at data like this. They look at data from business entities. They look at it from customer perspective, from customer relationship perspective, from retention perspective, how you can map the business entity and the business understanding of data to the core technical level of data. This is also another mapping that needs to be done and need to be governed. Because actually, surprisingly, even the concept of a customer is completely different if you ask everyone. Some people will refer to a customer as personal information, name and date of birth and profession. Some people would look at the customer from how much money does this customer ID make. I don't care about his name. I don't care about the customer name. So even the notion and the definition of a single entity can be really different. So how you can map and collect all of these different business meanings to map it into one or more technical entities, and how you can basically consolidate all of that at once. So as you can imagine, even on the data management layer itself, there is a lot of analytics that needs to be done. There is a lot of processing that needs to be done. There is a lot of graph processing. There's a lot of semantic analysis of understanding the meaning of everything that needs to be done. So that's why we see that the more you grow, if you are planning, or even if you're thinking with 1% of growth that you're planning and you're expecting maybe your idea is going to grow that big, you really need to have your data management layer laid out and laid down and implemented properly, because once it grows, there is no way to go back. Otherwise, you're going to break the whole thing. The interesting thing about this architecture is that it's very pluggable and it's very scalable. So you don't have to implement every single thing unless you really need it. And once you need it, as you can see, like it's really serverless. So it would start and it would end without having to consume money. The definitions are there. So you are basically having your cost under control and you're having your architecture with resilience. So coming on top of that, you can see now we can focus on the data landing zone itself. On the data landing zone, we can split it into 3 elements: core services and optional core services, and then eventually the data products. The objective here from this architecture is to make sure that every unit or every team or every department is capable of focusing on the domain. What we define by, or what we call as a data landing zone, is basically the domain zone. So a travel agency or a real estate agency, they can focus on their domain and they can build the analytics and focus on their business without having to go through all of that has been built before. So then now they can really focus on that. In order to do this, then they can have different types of storage, how they are going to ingest the metadata, what are the runtimes that are going to be there. All of this can be basically laid out. So this is how the architecture would be done. And then eventually, what are the analytic services that would be there? And are you going, what technology? And this is where we can trim down the technologies to something that you know that you will need in the future as well, that is resilient, that is having a lot of and high rate and high ratio of adoption. For example, like with Apache Spark or Apache Flink and the likes of it. And then eventually, when you focus on the data products, this is where you can provide the actual product that you are eventually, this domain is focusing on. Either it's going to be, for example, some dimensions, some analytical dimensions, or some data products that are there. And, or for example, some cognitive capability. Like, for example, with Uber, in the US, when they are, the drivers, when they are working, before they start the drive and they start becoming like Uber drivers, they have to authenticate themselves with their face to make sure that it's not someone else that is driving the car. And this is happening against, for example, the Azure cognitive service for the facial APIs. It detects the person, it identifies that it's him, then okay, you're good to go. And then from now on, every now and then, there is always some verification that is required that is actually more human. And this is what we call as applied AI. You are not just applying or like doing some basic AI, but you are actually putting it in there. And this is where we have the pre-trained models that you can actually deploy and you can use. So yeah, so this is how eventually it would be. And you can see here, oops, that these data applications can just scale up as needed. They can replicate as you need. So basically the resilience is maintained within this architecture. Okay, any questions? Any questions, comments? About serverless? Yeah, so what about it? Can you raise your voice? About the serverless. So basically, when you build an application, okay, so he's asking about, just to add some description or some information about serverless. What is serverless? Basically, in order to build an application, like there is a trend in application development by adopting what is called as microservices. Microservices is basically composed of, instead of building a monolithic application that you have to build every logic and everything in the same place, basically you are breaking it up into smaller microservices. It doesn't have to be like molecular microservices. A microservice can contain maybe multiple microservices, other microservices. Eventually it should be working independently. And in order to run it, you need to have some compute for it. So there is a lot of notion about running microservices in containers, for example, in Docker containers or in Kubernetes and so on. But this also can maintain also a lot of compute that is constantly running, because eventually this cluster has to be running to run your container. So although the container or the microservice can be decommissioned, but the actual underlying infrastructure is still running. So the cloud vendors have created what is called as serverless compute. So you can focus on your workload, on your microservice, you can push it and deploy it, for example, as a container or just as a binary, regardless of the technology, .NET or Java or Python, it doesn't matter really. Once it's deployed, once it's needed, the cloud vendor will allocate compute for it to run, and then it will decommission it. So it's much cheaper than maintaining your own container orchestration and container execution environment. So this is what the serverless is. This is an interesting question. So how each microservice will communicate with each other. Communication between microservices can happen. There is a lot of discussions around it. When you go into like the patterns of how you can build microservices, there is different ways of communication. If those two microservices have to stay alive, and they would be communicating and interacting with each other in a pub-sub approach, or through like RESTful endpoints, or through the data itself. So maybe the microservice would write into the data, and then the other one would read from it. There is tons of different patterns in it. But the main objective is that eventually you can have a callback, and you can always have like an understanding of when a microservice has finished the job or not. However, the general kind of like ruling, or kind of like de facto standard when it comes into microservices, is that they shouldn't be long-running services. So there is a notion of maybe it would be running for 30 seconds or maybe a minute, and then it should be basically completed. If it's taking longer, then you either need to troubleshoot it, or you need to break it into like sub microservices. So we are done with this section. Shall we go with like a short 2 minutes break or 5 minutes break? Before we start? We can continue, sure. Yeah. Okay, perfect. Okay, perfect. So basically what I have explained. Oh, it's I need to resume screen sharing. Okay. Okay. Are we good? Okay, cool. Okay, so what I have walked you through before was basically the foundational parts: how landing zones are created, how data management landing zone is being like should look like, and how the data landing zone or the domain zone should look like. So now I'm gonna basically like build on top of that and walk you through how modern analytics and governance happen at scale. And basically, this is like a hybrid approach. And why we are talking about hybrid? Because you can rarely become only cloud native. You can only run your operation only on cloud. Some data must stay on-prem. And this is what we have heard always from customers. Data and analytics operationalization. We need to speed up and optimize how we operate and how we operationalize our data estate and our analytics ecosystems. We need to reduce cost of data engineering. Surprisingly, actually, building machine learning models is not that complicated compared to cleaning and preparing and engineering your data. So if you're going to look at it from the ratio of effort, it can be 80 to 20% of the effort. You do 80% of the effort to prepare your data rather than you're just focusing on your machine learning. There is need for frictionless data governance. As I said, data governance is a nightmare for a lot of organizations. I can give you an example. Let's say that there is someone that is authorized to access certain data. And based on this authorization, they are able to operate, analyze, and get very interesting insights. However, there is a policy that may dictate that if someone is trying to access this data, even if they are authorized to, but from outside of the country, they shouldn't see specific columns. How you can enforce such a policy if the data is just laid out as text or even in a table? It's very, very complicated. The issue becomes even more interesting even if this is allowed, but combining two columns from two different data sets together to generate a report might not be allowed. How you can enforce such a policy? And it can get even more interesting if those two data sets are not even in the same source system. One of them can be as CSV or can be as a Parquet file or a Delta file, and the other one can be in a database table or can be, for example, from another different source. It's very, very interesting. And how you can control the access. And governance is not only about access control, it's also about lineage. It's also basically understanding where the data that I am looking at, how and where did it come from? What processes did it end up until it landed in here, in my hands? How can I know the authenticity of this data? This is a very, very difficult question to answer if you are not governing the actual ways and the actual steps that you are processing the data. And the whole process gets very complicated if you are building a machine learning model, because the machine learning model will provide you with certain predictions, and you can never be sure if the model has been poisoned or not. It can be poisoned easily by injecting bad data or by biased data. And this happened. You can see how a machine learning model can build bias over time because it always evolves. It always builds and skews towards certain thing, basically. So how you can enforce all of this, how you can know that this precision of the machine learning model is coming from this specific data, and how can I improve it? How can I compare it to the previous models? How you can manage the whole machine learning life cycle. So all of this is actually kind of like asking for building a unified ecosystem. We need to have a unified ecosystem in a completely shifting and a completely decentralized way and in decentralized world. So we try. So we try to align to 3 different layers of architecture for data mesh. One is the utility plane. And this is basically where we can have a consolidation of all kinds of data stores and data sources that exist and maybe an organization would need. And this would go in combination with networking, whatever connectivity that we have discussed, along with implementing the CI/CD, like the continuous integration, continuous deployment, to make sure that whatever work that the people are doing is always continuous. And in the same time, there is always automation that is happening whenever there is an engineering workload that is done, then basically it gets pushed and then the data gets processed. So basically, this is where the utility plane is focusing on. So you can see now, like we are looking at the whole idea from so many different angles. It's like a three-dimensional cube. And with every angle, you look at it from one area. You look at it from infrastructure perspective and identity and connectivity management. And then you look at it from another angle, you look at it from a data management perspective, governance, and then you look at it from another angle, you see the data, the domains, and everyone is focusing on their own domains. How can I build a domain zone? How can I build and make sure that the domains, when they grow, they can grow seamlessly without having to be hindered or blocked by the IT or by the resources. And then now we are looking at it from governance and how we can build this governance with resilience again. So this is basically the three layers to the same cube that we are building. When we look at now the data product experience plane, and now this is where this maps really closely to the domain that basically I just explained on my last slide. And that's basically when we focus on the actual data product that the domain is making. The travel agency is focusing on certain areas, certain specific things, the customer interpretation for them, and how they can create this information, how they can read it, and how they can version it, and how they can secure it. This basically how we can govern and provide governance for the data product, for the domain specifically. And then eventually, we go up higher layer, like a higher up layer for the mesh experience layer. And this is where we can define the policies, and we can enforce the policies, and then enable the discovery. This domain, the real estate domain, have created these data sets, and they would like to monetize on it. How they can monetize on it, how they can, for example, sell their insights. If you combine it with a travel industry and they want to monetize on top of it, and they combine all of this, you will have a very, very valuable data product. How you can sell it? Are you going to sell it with a contract? How you can maintain the contract? How you can maintain all of that? Basically, this is what we call about the mesh experience. If you see on the right here, we are combining all of this, and we're basically empowering that, or basically you need to empower that with the automation services. So doing all of this requires a lot of automation. Otherwise, it will become very, very tedious. So just to go back here, I want you to look at this, polygons. You can see the blue ones are representing the data domains. And this is what I was explaining about the data landing zone. And each domain is creating its own data product, right? So the data domain can become, for example, if you look at it as finance, marketing teams, real estate business, or travel business, shared services in the IT, whatever the domain is. This is what the domain would do. And what you need to have is basically a way of providing this governance in terms of domain-driven data ownership per domain. You want to enforce data as a product per domain. So the finance would be responsible of their own product, and then they can generate the reports, they can generate their forecasting, they can generate their own reporting, and push it upwards, for example, to the executives with confidence, because they own the information, they own the data, they can run their own simulations. And then eventually, the federated computing governance itself. So the governance is happening, they are part of the governance, but they are leveraging it. And then the technology team, or the landing zone, the data management landing zone in the middle, is enforcing this governance for the compute, for the processes, for the data, etc., etc. So this is how you can see that. So in a specific domain, in any domain, when we look at any domain, and when they build their own data platform, they usually get into this, like an architecture that is similar to this. This is where people tend to go. Like, yeah, we have all of these different data sources. We're going to build our data lake, and we're going to have all of the data in this data lake. What happens is that, or the wish is that eventually we're going to do a lot of processes. We're going to have data science on top of it. We're going to push it to a data warehouse, and we're going to stitch it with tons of different data integrations. And then eventually we're going to have an awesome BI and business intelligence and reporting, and a lot of apps that will be interacting with it. Initially, it works, but usually it tends to happen, like what happens is that this data lake, it turns into a swamp. The hygiene of the lake is very difficult to maintain because you are maintaining a lot of different layers and a lot of different data. There is no governance in here. The data scientists don't care about the hygiene of the data. They are very, very functional. It's their nature. Data scientists always look at the data, they process, manipulate, play with the data, get some insights, and then push it, and that's it. Job is done. They don't care about what they have left behind. And maybe someone else will pick up, hey, this is an interesting data set, but maybe it's outdated. There is tons of mess that can happen. So the governance, that's why we always see a lot of data lakes that have become swamps. It's very, very difficult to manage, very difficult to clean up. And basically, it ends up that there is no confidence in the data. Basically, people loses trust in data. And because of that, forecasting cannot be happening. So people do it because where is my single source of truth? It's gone anymore. It's not there. So, and add to that, security and privacy challenges, governance and compliance, availability and recovery. The data can be lost. The data lake is gone. Even if I have like 3 replicas, like this is like the de facto standard that you have 3 replicas, but then surprise, surprise, you're having it on the same disk, and the disk is gone. So, or the same data center, and then the data center is gone. Then basically everything is gone. So, and then the performance. The more data that you have, or the more computations that you have, if you want to run multiple simulations, you cannot have that with the same underlying infrastructure. There is a lot of people that are accessing it. There's a lot of people that are asking questions on the data on the same infrastructure. So eventually this server or this CPU or this processor has capacity to serve all of these different requests while processing and crunching data to generate new data products is very, very challenging. So what we try to do is basically to provide what I was talking about, like providing a unified experience, a unified platform, without having in a very dynamic and a decentralized world. And this is our approach of how we can achieve this. We have this service, it's called Azure Synapse Analytics. And basically, this is our approach of how we can build a unified and secured and integrated ecosystem that enables data scientists, data engineers, and business intelligence folks to work and collaborate together and have an autonomous orchestration, have an autonomous integration, and provide them with proper management. In the same time, the ops teams, the operation teams can control what is happening, can know what is going on and what goes wrong if it goes wrong. This unified experience runs and provides 4 different runtimes. A SQL data warehouse. So basically, this is where you want to have your data warehouse cubes and facts and dimensions for the semantic layer, so you can enable and empower the business intelligence folks. And a Spark engine. I'm not sure who is familiar with Apache Spark and who's not. Used to it? Who's not familiar with Apache Spark? Okay, maybe I can just say something. So Apache Spark is an open source project, and it's the most contributed open source project in the past few years. And it provides basically a blazingly fast data processing capability. And it provides a lot of advantages that you can write with multiple languages. So actually it provides a lot of comfort to a lot of basically the wider scope of engineers and analysts. People can write with Java, Scala, Python, R, and SQL on the same platform, and they can build data science, they can build deep learning, machine learning on the same environment. They can process data in batch, they can process data in real time, in streaming, in the same platform with the same API. So it's providing a lot of capability. However, although it's very, very powerful platform, but it's very difficult to tune. It's very difficult and very challenging to put into production. And what we have done is basically that we have brought Spark into production and becoming basically a production-ready environment. So you don't have to tune it, you don't have to configure the partitions and the tasks and the executors and all of that. We have taken care of that. You can just write your workload, run it, define whatever scaling parameters, and then it will scale up and down. So we provide also, Synapse provides with this, like the data warehouse capability through what we call as dedicated pools. We have also, like it provides you with a Spark, open source data engineering and data science and streaming and real-time processing capability. And then we have the serverless SQL as well. So maybe you have stored and you have persisted your facts and dimensions on the lake in one layer, and you are only going to ask ad hoc questions on them. You don't need to maintain infrastructure for that. You can just have serverless compute that is dedicated for SQL queries that will eventually serve data products and eventually will serve reports. So for example, an executive that is interested in knowing the state of the company or the state of their wells, or like, oil and gas wells, or whatever, energy, or whatever, the use case is, Uber like of services and so on, they would like to see the state. They can just open up the report, it will run a serverless query, get all of the data from all of these cubes, and then it's done. They are well informed, and at the same time, they are very well cost managed. And then eventually, the last runtime that also we provide is called ADX. It's called Azure Data Explorer. And this is basically, and it's tailored for what we call as time series analysis and time series processing. There is different types of processing when you are talking about data. There is the traditional way of you trying to understand how your data looks like, and how, if the data is passing on, like if you want to process the data in real time, or you want to wait until it's stored. Some aspects of the business would consider, if I wait until my data lands in the storage or lands in the database, I am already too late. Although it can take like few milliseconds, but that can be very late in certain scenarios. For example, in aerospace, in aviation, you cannot wait until the data lands in the database. Otherwise, people's lives at stake. So you have to really process the data in real time, in streaming, while it's actually floating, before it gets persisted. And when you look at this streaming aspect, there is always this temporal element that comes with it. There is always the time element that comes with the data that you need to look at it. You can think of this, for example, in fraud detection. Someone has stolen your card and running like crazy, doing a lot of orders. At this time frame of few minutes, it's only this time window that the bank has the chance to detect the fraud. This is basically what time series analysis is about. So collecting all of this information from all of the transactions and trying to detect the anomaly. And then we find it only in this time window. So basically, the ADX basically empowers you to do that in very simple, convenient way of querying. Beside, of course, like Spark can also allows you to do that, but in a different way, in different technology. So basically, we're trying to provide and mix and match between the convenience from engineering and science perspective, as well as also the convenience from platform and governance perspective. This is basically our approach of how we can solve this complex issue. So eventually, this platform also, like, we're not living in an isolated world. So there is tons of information. As I said, it's a hybrid world. There is a lot of data on-prem. There is legacy systems that people cannot change. So we have to deal with the fact, and we have to accept it. We cannot just modernize and change and say that it's our way or the highway. No, there is existing systems in so many different business disciplines, government disciplines, or security-based disciplines, a lot of security data and data that cannot move and cannot be leaving its premise, but yet you need to have this power of compute. So how we can deal with it? The platform also provides you with the right integration. So regardless if this data is on-prem, or you are using data, for example, from another cloud, and the list basically goes on. So all of that is basically surrounded by what we have been talking about in the data management zone and the data landing zone, from governance, where you can track the lineage of the data, how you can discover the data, how you can share the data, how you can create contracts, similar to how, for example, smart contracts are running, how you can create contracts to monetize on your data. You have created a new data product, a new insight. For example, you have observed through your data that there is a lot of marketing potential if you sell the insight, not the data, but you can sell the insight to, for example, retailers, and then the retailers can benefit from the insight. So you are creating a new ecosystem. In order to create this ecosystem, we provide you with a data share, how you can create contracts that you can monetize on top as well to sell your insights that you have basically spent your compute money to generate. And then eventually, you can also monetize on the dashboards. So the dashboards and the reports is not only for your own intelligence to understand what is happening or what has happened. You can also monetize on this. You can build on top of that as well. So this basically, when you start building all of these different domain zones and surround it with a data management layer on top, you will get your catalog, so people can find the information and the products. They can add, if they have created new products, they can add it into the catalog, and they can classify. So the information security teams and the data governance team, the data stewards, can start owning data, owning the domain, and maintaining the hygiene of the domain. And then also understand where this data is coming from. This is what we call as lineage, how you can understand the lineage of data, that this product has come from this service, has come from this job, has come from this process, has come from this raw data, from this source system that I don't maybe control. And the machine learning model is providing this result because it was trained on this data set, and this data set has come from this job, has come from this accumulation of those two different and multiple different sources, and so on and so on and so on. And then you can enforce the policies. At some point, you are authorized to access the data. At some point, you shouldn't be authorized to access the data. How you can control that? You can imagine how this can happen, for example, in accidents, and where people can usually, in normal day-to-day business, they can access their data and process it. But maybe there is an accident that has happened in the work facility. No one is allowed to touch the data anymore until the investigation is done. How you can enforce that? You need to enforce that. Especially, imagine this: the data is scattered everywhere. The data is in a massive distributed data lake. How you can enforce that? You need to enforce it. And basically what we give is basically the tooling of how you can enforce that. And then eventually the data sharing. So when we talk about the domain zone, where basically the data scientists lie and stay in, regardless of the domain that they have, how we can implement this. So by going back again and taking a step back into architecture, how we can design, how we can provide a design thinking around this, how we can lay it out so we can basically implement it eventually. And this happens by what we call as a tenant storage. We will implement, each domain will have its own tenant storage. Or this tenant storage will be just common across all of them, and it will be in the data management zone. So the data zones are scattered everywhere: marketing, finance, shared services, operations, engineering. And this data tenant storage that will enable the communication between domain and another can be either on each of the services tenants, or it can be a shared area where people basically can leverage this data lake. What is important, if you are going with this approach, is to have the automated services that would allow all of this. And when I say all of this, I mean literally all of this. The creation of everything that you have seen with all of these different scattered services and the scattered capabilities, how you can automate creating it. You cannot just go and do it manually. It's very tedious. So the automation to create the domain zone itself, the data product onboarding, the data agnostic ingestion, so how you can make sure that each domain and each person have the right tools once they log in, once they open. So basically, this is also something that you need to consider. And this is also one thing that we provide out of the box. All of this is also available for free. So we don't require any, you don't require any payment for this to basically build the automation. And then eventually you provide you also with the tooling how you can standardize on the data, as I was mentioning, for example, the definition of customer and the definition of all of that. We provide with all of these discovery tools that you can also leverage. And then eventually, like some perform some like data quality checks. For example, if there is a lot of nulls in the data, or there is a lot of some discrepancy in the data, you can also perform that in this automation generic layer. So diving a little bit on the technical side of how actually this would work. When you build the automation, you will have this data agnostic ingestion service to process the data in so many different ways. It's either that you are going to pull the data and store it in the landing zone of the data itself, and then start processing the data and curate it into a more conformed layer that people agree on their formats, agree on their expectations of this data, and then you start processing it to another layer where basically it becomes a standardized, which, for example, business intelligence teams or applications can start processing it. Or it's other data pipelines that are going to push the data to you. And this is also another interesting aspect, that you can assume, sometimes a person assumes that, okay, I'm going to give the data, but the question of how the data I'm going to get it's very difficult, actually. It's not an easy answer. Twitter, for example, provides you with a pulling mechanism, and sometimes you can subscribe. Sometimes you don't only need data that is external, but you need data from people that are actually consuming. So you need to subscribe to the events that are being triggered by their data usage. For example, someone is using a storage and they're creating their own data sets. You need to have event to capture these events that a new data set has been created. You cannot wait for this person to finish it. So you need an automated listener that will listen to the storage and detect that there is a new data set that has been created and send an event where an automated job would go and pull it. Otherwise, you would be basically just going back into Stone Age and wait. So when it comes into data standardization, we are always referring to what is called as like multi-layered data lake. When you have an on-prem system, or when you have like an external data source and you are pushing the data or you are pulling the data from, eventually the data needs to land somewhere in its raw format where people can start processing it and start building some initial insights and understanding of what this data look like. This is what is called as the landing container or the landing layer. Once this happens and you have all of this data, for example, from Twitter, from weather, from geopolitics, some location data, some telco, some computer vision, images, security cameras, whatever that you're going to do, whatever the use case is, it lands as is, and then you start processing the data. You start conforming the data. For example, as we're talking about, for example, security footage, and you want to process and you want, for example, to detect maybe people that are entering a certain facility without the compliant equipment, helmets and glasses and stuff like that. And the cameras are not well established. They are established like here and there and maybe there, and the distance is quite an issue. So you need to normalize this data. You cannot just take the image and just process it on it just as is. You need to normalize it to a certain format with certain colors, and basically to get and trim the noise. This is how you conform. And then basically, once the data has been conformed into something that is a little bit more standard, then it can get into the actual pre-processing or the processing pipeline, where it starts basically extracting all of these features and then convert it into matrices, and then basically you can extract all of these features. So the preparation of this layer is very, very important. So some errors can happen. Some data can be corrupted. Some data can be completely conformed. Maybe you are waiting and you are reading or you are ingesting from an elevator sensor, and the sensor has gone kaput, as we say. So you cannot get, it sends corrupted data. So you need to capture all of these also errors, and then you can start analyzing, either by trying to fix it or at least capturing it, and then that would go into anomaly detection kind of like pipeline, and then that would trigger that maybe there is something wrong with the sensor. Once you're done, the output of this would go into the second layer. Second layer is basically the enriched data layer. The enriched data layer can either combine or like process the data into a conform formats, for example, or can enrich it with multiple data sources. Maybe you want to combine these data sets of images, maybe with weather information, and you will have them in one data set that maybe will be useful later on. Depends on the use case. Once you are in the second layer of the data lake, of the enriched layer, you will have basically the standardized like container, because you need to have and capture everything. And this is what is important about big data. We do say that people don't know what they don't know. You don't know what is useful or not. And you don't know if this information, it might seem unuseful for you now, but it might be very, very useful later. So you really need to capture every single thing because it's very important. So the logs, for example, is very, very important. The logs from people, the logs from the systems and applications, the telemetry that is being sent from every single sensor, as well as also the services that are receiving from the sensors. The transactional data, the unstructured data, all of that needs to go into this layer, and you start standardizing it. And then you will have multiple separations. Some of the data would go into the development approach, where engineers, data scientists will start operating and processing on it. And others would go into the analytics sandbox, where people can start asking questions on this data, trying to understand what has happened. And this brings us to an interesting question. What are the types of analytics? There is multiple types of analytics. There is a descriptive analytics, and that's basically trying to understand what happened after the fact. Why my customers are leaving me. My customers have already left. I'm trying to understand what has happened in the past. And this is kind of like the lowest level of analytics. Then comes basically the prescriptive analytics, where I try to protect and try to predict what is going to happen. Are my customers going to leave me? Then why? I would start understanding what is going to happen. And then basically the proactive or the predictive analytics, which basically is that your customers are going to leave you because of these incidents. And that can happen by detecting the sentiment, for example, from the customer tone when they are talking. The AI would listen, would notice the tone change, it will pop up, your customer is not happy to the service agent. So instead of agitating or making the customer service agent nervous to respond with to the customer, they would understand that they need to calm the customer down, and the AI would provide basically this recommendation because it detected the tone. Usually humans get offended when people change the tone, but AI doesn't. AI will detect and will understand and will provide a recommendation and a suggestion. The same also that, for example, as we are talking about customer service, retention of customer service agents is very, very difficult because they are under so much pressure. So customer service agents are really suffering. So coaching customer service agents is very expensive. So a lot of centers are really suffering to serve, to train those agents. That's why a lot of centers are providing very, very poor quality customer service agents because they didn't have time to train them. But if they're using AI to coach the agents on exactly what to say, they don't need to train them anymore because the AI would be trained. The AI would listen, would understand, would know that this customer is very important for us because they are spending X amount with us, so their score with us is very high, and they have changed the tone, they have complained multiple times, then I'm going to provide this tailored message, this humanized message. And you can see like there is tons of different AIs, disciplines that we're talking about. Speech, natural language processing, and natural language representation. And it can even go into, like predictive analytics and anomaly detection, which is basically like the stochastic and the statistical analytics as well. So as you can see, the analytics is very, very important on all of these different levels. So here, with the analytics sandbox, this is where basically you can come up with all of these different analytics products, and then you can come up with all of these different insights and even ideas that maybe the organization is not having. So eventually, you will end up into something similar to this. You will have, your physical layer with the different lines of business, different schemas, and different, business domains, and then how you can enforce governance on top of all of this, regardless where the data is stored. If the data is stored in legacy systems like SAP and HR systems and so on, how you can enforce an overall governance around all of this while you are actually in the cloud, while you are outside of all of this ecosystem. So yeah, eventually you will start having. Basically, you will be empowered now once you have this architecture and this governance. Discovery of information will become much easier because you have conformed, you have built your analytics pipelines, you have built your products, and all of that eventually goes into a governance landing zone that is scanning all of this and building relationships on its own. It understands that this information is related to this information because there is a processing pipeline that has happened here. So yeah, with this, I finished my second presentation. Any questions?
I think I know one.
Sure.
So you mentioned about the data closing with the machine learning data model.
Yeah.
So the main idea of the machine learning is that it will evolve, right? So why would it be something that it be considered as a data closing? Because it's just working on its own.
Well, this is a very good question. So you're asking about data poisoning, and although machine learning model evolves, why do we consider that this could be, for example, as poisoning? Right. So actually, poisoning can happen on on multiple aspects. Poisoning can happen by, for example, purposely inserting or giving the model wrong data or biased data. Like this happened in one of the Microsoft has released like a trial, a scientific kind of like experiment on Twitter for a chatbot, like it's public, and it was very humanized. So people were asking a lot of questions, a lot of things. So basically, it was a reinforced learning model. So people were asking a lot of questions about a lot of topics, and the model has deduced that these topics are good. So, for example, it was talking about Hitler, and a lot of people were asking it a lot of questions about Hitler. So it started deducing that the Hitler kind of like topic is quite a positive thing. So it started praising Hitler. So this is type of poisoning that basically people are feeding, or someone. It can be on purpose as well. So people can generate certain bots or certain automated jobs that can generate poison data that can poison eventually and poison the judgment or the prediction of the model. That is one aspect. The second aspect is basically, as data evolves, usually data leans into certain thing, and this is what we call as building bias. It happens also in AI a lot, and you can, like one thing that you can relate to, for example, at some point, Google image or facial recognition model, at some point was only recognizing white faces. It was not recognizing any black faces or any colored faces even. So because the data set, the majority of the data set that has been trained on was basically on white people. And that raised a lot of basically like the idea from research that yeah, poisoning can happen and data skewing can happen, and that can impact how AI is actually performing. So from machine learning perspective, it's very, very important to control and understand the bias. And having like a 96 precision or like 98 precision, that doesn't mean that there is no bias. You really need to detect is your data that your model has been trained on, is it really balanced or not? So it can really provide, and it can also, accommodate for the edge cases if it happens. So this is basically why poisoning is there, because at some point you don't want your model to keep just leaning, right or leaning left and just give, certain predictions in this area, because the majority of the data has come. So you really need to understand, and you need to normalize it so you can make sure that you are providing an actual, with an actual precision and actual accuracy.
Okay, so am I going to normalize the output by continuous governance on the development itself, or by monitoring the data which is being consumed by the platform?
It's going to be actually on both. You need to enforce governance on how the data is actually flowing and what is the quality of the data. is the data is coming with good quality or not. And you need to monitor the performance of the machine learning model itself, and how is it evolving, and how often actually are you training it, because there is a lot of different ways of retraining the model. Are you going to retrain it only on subset of the data set that has just come, or are you going to retrain it on the overall data set all over again, like after you have built more data? And there is no silver bullet for like answering this, because it might seem to be wise to train all of the data set all over again and again, maybe every week or something, but it could take so much time. If you are looking at like internet scale data, how much compute and how much data is in there. So there is multiple techniques that you can also enforce in there. And then when you release a new machine learning model, like you have released one, and it has been performing pretty well according to the data set that you have, and then you have started accumulating data, and then you retrained it, maybe you followed one of the techniques, transfer learning or whatever, to train and to add more layers that are trained on the new data while leveraging the previous ones. And then your new model has been deployed and is serving now in production, and you need to measure and compare the precision and accuracy across both, and then the ability also to revert back. Maybe the new model or your new technique even is not performing well. So you need to have also that ability. So the governance is not only on the data, is not only on the people, but also on the AI itself and the machine learning models that you have, and how you can version them, how you can benchmark their performance, how you can revert to the actual data set. Because look at it from training perspective. You have a data set, you have a folder, you keep adding files in it. Okay, but I want to revert back. I want to retrain my old model on my old data set. So you actually need to think of it from dataset versioning. I want to version my data sets. And then that actually drives you into another kind of like completely different tough topic. How much will it cost me? For how long am I going to version all of these data sets? They would seem to be replicated in a way, right? So eventually, of course, the cloud gives you limitless, storage, but that comes also with cost. So you have also, this is basically where we need to think about it from all of these different angles. So this is what we refer to by, either by model skewage or model poisoning, as well as also the governance of the model and the management of the models itself. And then eventually also how you are going to serve it. So you created your model. Where is it going to be deployed? How is it going to be served? Is it going to be served on a web service, or is it going to be embedded in a small sensor on a device that is going to be, for example, like cars cannot query a model that is deployed on a web service. Maybe they will get it if it's something related to retail, and maybe you made an order through your car, like Starbucks or something, and you want to get your drink, so the car will do the order for you in the right time and moment. Yeah, that can happen. But an actual decision that maybe a self-driving car would take, or maybe a flight, an aerospace or an engine, no, that it needs to be embedded. So how you are going to serve it, and then how you are going to control it, how you are going to push a new model if this model is not performing well enough. Like, for example, this aircraft accident that has happened because of the wrong AI. It was kind of like flipping the flips on the wings. So this incident was basically it was because of a miscalculated precision from accuracy and recommendation from the autopilot. The autopilot detected there is something wrong, so it was kind of like flip the flight, and then boom. So these are the things that are very, very important basically to consider in model management and so on.
So one more question about this Azure data export service, right? It's available in the EU region.
Yes. Yeah.
So I think it's like computed every it's available, right?
No. It's also serverless. Yeah. So yeah, we can discuss about it if you want. Okay. I am ready to go if you want, to continue. Do you want to break or want to continue? Thank you. So shall we move on? Break? Faster? Okay, cool. Okay, perfect. Okay. Okay, so now we have spoken about cloud scale analytics. We talked about data governance, data management zones, and data landing zones. And now we are going to talk about how you can apply data mesh to your organization. So data domains. So we are going to make this example on like a fictional kind of like company. It's called Tailwind Traders. And it's kind of like a travel company. So there is a lot of kind of like, use case just to tailor the domain. So data mesh usually refers to a domain-oriented, decentralized data ownership. So, but the subject is actually quite, although it's like picking up a lot of attention in the field, but it's one of the most difficult kind of like concepts, because domain-driven design is very, very difficult to get grasp on, because eventually the domain is very, very sophisticated. Travel business is different from marketing, different from finance, different from banking, and so on. So each domain and designing for each domain is very, very difficult. And it gets really complicated if it's an organization that has combining all of that together. For example, in oil and gas, you have trading, you have marketing, and you have banking, and you have finance, and you have all of these different disciplines together, beside the core business of oil and gas, for example, drilling and upstream, and then you have the supply chain and the piping and all of that. So the domain driven design is very, very difficult, and can become very, very cumbersome when you look at it from that perspective. However, it helps to set this logical, separation. Then you can really focus on each domain and each specifics, and then you can design it against it. So on the screen now, you see like this decomposition of the domains by the discipline. So for example, we have like the supporting service management in this company, and this would go like with the cost management, with the IT service management, with the partnerships and the emissions and trading management. So all of these are shared domains that are going to be serving the above layers. You will have the travel management, and within the travel management domain, you will have the money exchange, you will have the negotiation management, the travel management discipline itself, and so on and so on. And then you will have the staff and personnel management, you will have the customer service management, like the CRM and the customer service with the telephony or with the chat, how you can provide an omni-channel experience that goes through telephony, social media, and so on. All of this would go into this discipline. So when you look at it from architecture perspective, you can apply the same principles that we've just learned by having a landing zone, a data landing zone for each of these domains. So you would have, for example, a landing zone for the online ticket management, and another one for the partnership and communication. And each of them is generating their own data products, or generating their own insights. But at some point, the customer service needs both information. So how we can empower this? So basically, we are enabling this through the communication between landing zones together. And that's when basically you start realizing the importance of this architecture, because you have built your shared layer that goes and spans across the whole infrastructure, and you have built your data management layer, and this where you will have the tenant storage, if you remember, and then you will have the data domains, and the data domains can communicate with each other across the data management zone. Otherwise, and if you go with different architectures, it will become very, very difficult to maintain and manage, and it will have like what we call like point-to-point communication that cannot be maintained, And then eventually, if one domain is evolving, maybe they are adding more information, maybe they are creating new products or new insights, or they have realized that the insight that they are generating is not really accurate enough, they have to change it. That means that you have to change it across everything. But with this approach, you can really standardize on it. However, this pattern can fit if you're having like one single landing zone. But imagine now that you're having more landing zones, for example, across regions, or some of the data that you cannot own. So you have source and destination. Yet you can still work with the same architecture, and you will have multiple subscriptions, and then you will be operating across zones. There is an additional scalability, and this is basically where it gets really interesting, how you can build something that is molecular and small at scratch, and then how it can really grow with you with the same resilience without having to worry about it. This third pattern would go and show you like it's functional across regions. And this is really important. Like, we call it situational layered cake. In every single region, in every single country, you have your own policies, you have your own regulations, you have your own disciplines and your own restrictions. So how you can tailor the landing zones across multiple regions, you can still effectively do it by having your own common layers of the cake, and then you can grow with the domains in different areas, in different regions, where every region will have its own business rules without having to impact anything here in the common layer. Any questions? Any ideas? Yeah. To this one? So let's take, for example, insurance business or insurance use case. Insurance business would apply according to different regulations, right, in each country. So as a multinational insurance company, for example, that is operating in UAE and it's operating in Europe, it's operating in Asia, each country has its own regulations. Like the same policies will never apply. So as an organization that wants to operate, or maybe banks, like EMBD in UAE or EMBD in other countries, like just an example, like fictional example. You need to have unified infrastructure that would operate and would allow the teams to operate and work. And you would have the data management, because you need to make sure as an organization that the data is being managed properly and is being governed properly. And then you would have the vertical data domains per country, per region. And in each country, in each region, you will have your own zone, basically. You will have your own business rules. And then you can enforce this. For example, the premiums maybe would differ. There is some kind of like government enforcement that the premium can never go lower below than this, or like the regulations can go below that. All of these different things, the domain experts would know, and you need to empower them from data science or from data management perspective. And that's how you can do it. So one region, for example, one data landing zone would be like a functional area that is operating maybe in UAE, another one would be operating in another country, and the ecosystem is operating and collaborating effectively. This landing zone will have its own data products, and it can have its own data, because maybe the country would say like, my data and my people's data can never leave my country. So fine, it will be there, but then the management aspect of it can be there, because maybe you want to provide your customers with a unified experience whenever they go. So they want to be known. When they land in a new country, they want to be known. But the interaction between the different systems this domain, for example, will not retain the data, but it will interact with this domain in a more governed way. So that's how you can enforce the policies and enforce the governance. This is really the value of it, because then you cannot expose the countries. Like this is one of the, for example, the challenges of companies here in UAE is that there is laws that is protecting the people living in UAE. So if a company wants to expose certain service, you cannot, unless you follow this pattern, unless you follow this architecture. Then you can create a product and basically just consume the product instead of copying the data or moving the data. Yeah? Okay, so this section is done. Last section, and this is basically where all of this exists, how to actually build it. Are we good? Okay. So as I said, everything in this architecture and in the cloud scale analytics, okay, everything that I have explained is actually available, as I said, online, along with the information. If you go to this website, you can find all of this information. So let me share the whole screen instead of just sharing a window. Okay. Okay, so let me take you here. Okay, so if you go to aka.ms adopt cloud scale, sorry, aka cloud scale analytics, you would land into this page. Okay. And in here, you can see basically everything that I have walked you through in terms of the principles, the implementation guidance, and links to the cloud adoption framework and how you can apply it. The Azure well-architected framework, how you can build well-architected frameworks that are resilient, that are scalable. And then eventually, cloud scale specific guidance for building an initial strategy, defining your plan, preparing the analytics state itself, basically how you can navigate through all of these different technologies, all of these different services, how you can pinpoint something that can go resilient with you, that can be reliable the more you go into the future. And then eventually how you can secure it and how you can organize people around your team. We also provide what we call as the team data science process, TDSP. The team data science process goes and also walks you through how you can build your team, how you can build your data science team, how you can build your data engineering team, how you can enable the collaboration between those teams, and how the whole DevOps process or the data ops process or the ML ops process would work, and then along with the management around it. And then eventually, how you can manage your analytics state and so on. Basically, once you have done your exploration, your analytics, your processes, you have pushed everything into production, how you can actually monitor it. How can that basically go into live, and how you can proactively avoid disasters or crisis into your business. Okay, let's go here. Okay, so with this link, you will have access to all of that. In addition to this, we have also reference implementations. So, and it's not just documentation and it's not just reading, but we have actual code and we have actual artifacts that you can deploy to Azure in a button with just a click of a button. Basically, we have all of this defined as templates, and all of this can be basically created in a few seconds. I'm going to also walk you through that. We have also what is called, I'm not sure if how well versed are you in DevOps or in data engineering or software engineering in general? We have in GitHub and in Azure DevOps, like we have two services basically for DevOps. We have GitHub and we have Azure DevOps. So regardless of what your comfort zone is, we have basically these pipelines and these templates ready for both. So you can create what we call as DevOps pipeline or GitHub flow, basically to automate everything in terms of creation, in terms of monitoring. If someone is changing, if the template is not up to your liking and you want to change something, you want to remove things, you can easily do that. You can push it, and then basically the GitHub agent or the DevOps agent will basically kickstart and automate all of this and create it for you. So we have built also the automation that is surrounding everything that I have spoke about. And all of this is also tested and validated. So you're not alone in this. All of this is public repos, and we have like very, very governed and strong and strict way of contribution. And we have also big like contribution bases on top of it. So those reference implementations, as an example, for example, the data management zone is available here on GitHub. Let me open up this again. Oops. Oh, it went. Okay. So this is, for example, the artifacts that that is related to building the data management zone. You can see, for example, in the last 2 days, there was like 643 commits. So people are really actively contributing here, improving tons of things. There is GitHub workflows. There is div container. So actually, you can, with this .div container folder, you can open directly to Visual Studio Code, and you can actually start contributing, or you can start editing and do whatever that you want. And with GitHub, you can even use something called code spaces. So if you don't have the development environment or VS Code in your own environment, like in your own machine, you can open VS Code in the browser. So this is like really, really cool. And then eventually, like the code itself and the artifacts, like if you are into editing or understanding it and understanding how it's being made, you can do that. We have also, like, people are contributing also into the documentation. So there is a lot of explanation in there that can make it easy to understand until you go into this interesting table. So this is where you can find the reference implementations that is related to the data management zone. So implementing a cloud analytics scenario end to end. So this basically would deploy the data management landing zone along with, in addition, with an actual domain data landing zone with a click of a button. If you just click on here, it will open up the Azure portal. It will just let you to enter some parameters. Yeah, let me just switch to my profile. Maybe I just do this. So this is basically the template. So this would create everything for me. Am I building this landing zone for development or for testing, for production? And then you can get into the definition of the landing zone, which subscription is going to run on, what is the location, because eventually you are going to provision this in a certain location, and then eventually the prefix of this landing zone. So basically, it would walk you through. Okay, we're good. It would walk you through in a wizard kind of like style of how you can build all of the artifacts that I have shown you before. And this would go for an end-to-end scenario, or only the data management landing zone, or the data landing zone only, or even just a data product for batch, like for batch processing, how you can build the capability and the artifacts and basically the domain for batch processing, or for streaming, or combined for both. So switching back to my slides. So the same also goes for like the data management, the data domain, the data products for batch streaming, and for the analytics and descriptive analytics. So all of this reference implementations is there. You can easily take it, pick it up, edit it, push it, and then you will have the artifacts. And this is basically what like we have here. So you have basically the capability end to end, and you don't have really like, you just need to understand how it works, and then you can pick up those reference implementations. You can kickstart them, you can see them, and then once you finish learning, once you finish your application, you can easily delete them. So yeah. So with this, I'm done. I hope that you found it useful. Do you have any questions, any feedback? Sure. Yeah. So I hope that you found it useful. Thank you so much.
All right, thank you everyone for joining us today, both in person and online. And of course, thank you, Ahmed, for sharing your experience with our community, both again in person and online. It has been a very insightful session. And thank you also for the Insights Lab and for Middlesex University for hosting us. Ahmed, you have been uh, sharing your experience. And again, thank you for having us, lead solution architect at Microsoft. We look forward to hosting you more at the Reactor. And for everyone here today and also online, if you are not yet part of the community, just go to meetup.com, look up Microsoft Reactor, Middle East and Africa. This is the meetup group name. We have a high frequency of sessions across different topics, AI, machine learning, data science, etc. And there are opportunities now for you to come back to connecting to the community members at certain locations and partner locations where we're going to tech hubs and some universities to deliver some of these sessions. But majority of our programming has been online, and there will continue to be a mixture of both. So if you happen to be in Dubai, I'm speaking to the ones online because I've noticed some of them are in Dubai. You could have join us today or in the future sessions. And for those of you who are with us today, if you happen to like one of the sessions and you cannot make it to the location, then you can join us online. You can check out the calendar for next month. There are also a couple of opportunities for you to join in person. That's all for today.
So there is just following up on this, we are going also planning to have like a series of hackathons and hands-on activities that are data science or machine learning and AI, applied AI related. So yeah, stay with us in the next few sessions. Like this is basically foundational now.
Awesome.
Yeah.
All right, thank you. I'm gonna wrap up on the online part, and we can continue to have some discussions and conversation.
Sure.
And we have some swag and some also pizza for us after the session.
Yay.
So yeah, cool.
So yeah, for the attendees, I hope that you found that useful. Any questions, any feedback, any